Welcome to section 9.7, polar graphs. So we're going to take what you have done previously in 9.6 and actually graph some stuff that looks pretty neat. So instead of having XY points, as you know from the previous section, we're going to go to our theta points. So I set up our table to go with our equation. And what we want to do is plug in the theta values because the r is what's isolated in the equation. So what I'm going to go ahead and do is just set up all of the values that we're used to from the unit circle as my theta. Okay, now that the thetas are all set up, what I'm going to do is just start plugging these values in. And I'm going to show a couple of them, but after a little while I think we can figure out what the pattern is. So for our first one, we're going to plug in 0. And I'm not going to necessarily show my work every time like I said, but I do want you to see that I'm actually plugging the angle in that I have chosen. So when I plug in 0 for sine, I get 0, and then 4 times 0 is just 0. All right, and then just moving along. So let's go ahead and plug in the first quadrant, and then I'll pause, and we should be able to find some values that match up from the first quadrant to the second quadrant, keeping in mind that we are talking about a sine function. So if you're talking about sine, that is first quadrant and second quadrant, sine is going to be positive in both of those locations. So I think we're going to have some nice little symmetry happening in this table over here. All right, so if we plug this in, I know that sine of pi over 6 is going to be a half. 4 times a half, that's going to give us 2. All right, and just keep right on moving through. Now I am going to write the exact values here, but when we start graphing it, we're actually going to come up with the, excuse me, the approximate values. So sine of pi over 4 is going to be root 2 over 2, times that by 4. That's going to give us 2 root 2. And then up to pi over 3, plug that in. And I think you get the idea. So what I'm going to do is I'm going to pause. I'm going to fill in the rest of the entire table, and then we're going to start plotting. Okay, so now we have our values for all of the increments that we're familiar with from the unit circle. You'll notice that from 0 to pi in the unit circle we are up, so our sine values are all going to be positive, and we do have some that match. It's kind of nice. But then from pi down, well, not including pi, but from pi to 2 pi, then we're going to be down in the third and the fourth quadrant, so our sine values are going to be negative. Because of that, we are going to be shooting through these points. So I'm going to move to the next slide, and we're going to go ahead and start graphing these. So you might want to have these points close at hand, so make sure that you copy them down, or at least have them down before we move on to the next page. Okay, so here we have our polar paper set up. I would highly recommend downloading some of this, and I went through and just identified where the increments are that we're going to be using. So what I'm going to do, every time I see a point from my graph that has a positive radius, I'm going to go ahead and plot it. Whenever I have a point where my radius is negative, I am going to mark it and then shoot it through. So here we go. So our first point is 0, 0. So that means we're kind of right in the middle here. So there's our first point. And remember, we're going to connect these in order. So now we go to the second ring on pi over 6. So go to where we have pi over 6 and go out to the second ring. That's our next point. The next one is going to be 2 root 2. So let's go ahead and figure out what that decimal is supposed to be, which gives us 2.8 approximately. So over halfway to 3, but not quite there. So at pi over 4, we're going to go over halfway to 3, but not quite there. Go ahead and plot that point. Then once we're at pi over 3, we're going to go out to 2 root 3, which is 3.5, or approximately 3.5. And then once we get up to pi over 2, we're up at 4. Let's go ahead and plot that. Now what's really nice about the first and the second quadrant, like I had said, is you get the exact same values. So let's just go ahead and kind of mirror that over to the other side. All right, so there we go. Pretty nice. We have all of our points dealt with in the first part of the table, and then the last entry that we have there is pi, or 0, pi. So we're on the 0 ring at pi, which actually just puts us right back to the 0, 0 point that we were on. So let's go ahead and connect these so far. And remember, we have nice smooth curves here. So we'll do the best that we can to make it look pretty decent. Oh, that one looks a little straight. Connect our dots. Nice curved pattern to it. Okay, so now let's go ahead and do the other points. So I'm going to go ahead and mark them in black, but then shoot through and color it a different color. So we're now at 7 pi over 6, and we would be on the second ring at 7 pi over 6. So 7 pi over 6, second ring, but that's a negative. So what we're going to do is we're going to shoot through the exact same distance on the other side. When we do that, we're going to go 2 rings in and actually 2 rings out. You'll notice that we actually land right on top of where one of the other points is. This is kind of nice. So let's go ahead and continue in that fashion. 5 pi over 4, we're going to be at that negative 2.8. But that's going to get shot through. And if you take a look, it shoots through to the other point that's already there, which is kind of nice. Actually, if you take a look, it looks like every single one of these negative values that we're going to be finding is going to shoot right through to a partner on the other side. And remember, it's not the marks that I'm making that are part of the graph, it's the points that are actually being plotted. Again, if we just continue through in that same fashion, every single one of these is going to be shot through to a partner on the other side. And then sends us right back. So we have all of those points that are actually just going to be, like I said, shot right through to where the other points are. So this graph, this r is equal to 4 sine theta, it's actually just the equation of a circle. Kind of nice. Okay, let's move on to the next one. Let's go ahead and change this back to graph paper. So we've got space to write. And go ahead and fill in the table. I'm going to pause right now, fill in my table, so pause, get them all filled in, see if we match, and then let's graph this. Okay, so here are the values that I came up with when I went through and plugged them in. I also went ahead and just put my decimal approximations there as well, so that when I start graphing this, I know where those actually are located. So what we need to do now is actually move to that next page. We're going to do the exact same thing that we did before. We're going to take every point with a positive radius, and it's going to stay exactly where it is. But every point with a negative radius, we're going to mark and then shoot through that point. Now I am going to do a lot of pausing, so I think what I'm going to end up doing is moving to the next slide, and then I am going to do the entire first column on the left-hand side, kind of get us started, and then I will pause, and I will do the one on the right-hand side, and then we'll connect the dots and see what this thing looks like. So moving to the next slide, let's go ahead and change this background again so we can see our polar paper. Oop, that's not what we want. And go ahead and fill the stuff in where we have the pi over 4, all the increments that we need, and then let's go ahead and start plotting. Okay, so just to get us started in the first quadrant, which actually has us shooting immediately, I'm going to go ahead and mark, we have a 0-degree angle, so we're basically on top of the x-axis, but we want a radius of -1. So what I'm going to do is I'm going to go ahead and mark the radius of 1 on here. It's going to be right there. But then let's go ahead and shoot this right now. So it's going to shoot directly over. That's going to be the first point that we're going to be using. So that's basically going to be our starting place. All right, let's go through and move on and do the first couple, and then I'll pause it and you and I can catch up together. So on the next one, we're going to be at pi over 6, and it's going to be at about -0.7, so more than halfway. All right, so we want to be on that, but we're going to mark it because it's negative. but then we're going to shoot through. So we're going to shoot across. Oh, let's get rid of that. We're going to shoot across, and we're going to plot that point. That's going to be the second point that we go through. And what you might want to do is actually connect the dots as you go, because it can get a little confusing sometimes. So we could actually connect those two red dots. And actually, let's go ahead and do that, just in case. Okay, so we know that those two are going to be connected in that order, starting from the left, working towards the right. All right, our next point is going to be at pi over 4, but it's going to be a negative radius of 0.4, so not quite halfway, a little bit less. But it's also going to be negative, so we're going to have to shoot through. So we're going to be less than half. Okay, let's go ahead and connect those dots now. All right, I'm just going to kind of keep working my way around. So the next one is going to be at pi over 3, and I'm going to be at 0, which means I'm on the pi over 3 strand, but I'm right at the middle. So let's go ahead and connect those, and since I'm already, nope, let's go ahead and keep it in black, I didn't have to shoot. So that would be our next connection. So why don't you pause? I'm going to go ahead and fill in the next part on the left-hand side, and we'll see how it looks. Okay, so after finishing the entire left-hand side, this is what I have. So it kind of looks like it's going to curl in on itself. All right, let's go ahead and finish. So make sure that yours matches mine. And I'm going to go ahead and pause and do the entire right-hand side and connect the dots. And then we'll see what it looks like. Okay, so it looks like after graphing this thing, this is what we get. So it looks like we have a circle kind of with a little loop inside of it. So it's important to keep track of your negative radii and your positive radii. Remember, the only ones that we actually graph or plot as part of our graph are the positive. Every time you get a negative, you're going to have to shoot through.